I'm Dr. Aneela. I'm working as Assistant Professor in Physics, BV Razu Institute of Technology, Narsapur. My course name is Applied Physics. But today I'm going to discuss on the topic of lasers. The outline of my presentation is goes like this. So first I'll discuss about the main components of laser. For any laser, three essential components are required. So I'll discuss the role of each and every component, and then types of lasers. The nature of based on the nature of active medium, the lasers are classified into four types. There are solid state lasers, liquid lasers, gas lasers, and semiconductor lasers. So today I'll discuss about the solid state laser. So example for the solid state laser is Ruby laser. I'll explain its construction, working, applications, and drawbacks of Ruby laser. And then I'll summarize today's class. So any laser, it consists of three major parts. The first one is active medium. The second essential component is energy source or pumping source. The third one is optical cavity or resonator. So here the active medium, it provides the set of energy levels to support the laser action. For example, if you consider the Ruby laser, so here the Cr3 plus ions are the active laser particles. The second component is energy source or pumping source. So it provides and it helps to provide the population inversion. Means it helps to achieve the population inversion so that the lasing action can be done. And the third component is optical cavity or resonator. So it helps to introduce the optical feedback, and so it maintains the gain of the system, overcoming all the losses. And depending on the type of system, optical feedback is provided with the help of two mirrors. So one is the fully reflecting mirror, and the one is partially reflecting mirror. If you see this diagram, so this is the active medium. So central part is active medium. And this is a pumping source, and in between the active medium there are two mirrors were placed. One is the fully reflecting mirror and one is the partially reflecting mirror. So the photons will move in between these two mirrors, and the laser beam comes out from this partially reflecting mirror. So if you see the schematic diagram for the laser, so these are the main components of laser. So this is the first component, that is active medium, and so here from this we will supply the pumping source or energy source, and there are two mirrors in between active medium. So one is fully reflecting mirror, totally reflecting mirror, 100%, and this mirror is partially reflecting mirror. This is less than 100%. Okay. So now I'll explain the role of each and every component. The first one is the active medium. So here we have the assembly of atoms present in the active medium, so that the population inversion is achieved in active medium. So from that the lasing action can be done. Okay. So depending on the nature of active medium, so the lasers are classified different types. So here in active medium, the atoms are available in different forms, either atomic form or ionic form or molecular form. So for example, if we consider the helium-neon laser or helium-cadmium laser, so here active medium is available in the form of atomic form. So if we consider the carbon dioxide laser, so this is a gas laser, so here the active medium is available in the form of molecular form. Okay. If you consider the dye lasers, so here the active medium is available in the form of liquid form. So in case of solid state laser, here for solid state laser, the Ruby laser and the diode laser is the best examples. So here the active medium is available in the form of solid state form. So on the other type of laser, that is semiconductor laser. So here we use the direct band gap semiconductors. The examples for the semiconductor lasers are gallium arsenide and indium phosphide crystals. So these are the different energy level diagrams based on the based on the nature of active medium. So this active medium is available in different forms. If it is a atomic form, the energy level diagram is like this. If it is liquid form, it looks like this. If it is a solid form, the energy level diagram for the active medium is available in the solid form. So it is for the semiconductor laser. So these are the different energy level diagrams for the different forms of active medium. Okay. So based on the active medium, the nature of active medium, the lasers are classified into different types, and the lasers are classified into different types based on the different concentrations. And some of the important types of lasers are, first one is solid state lasers. Here the examples for the solid state lasers are Ruby laser and Aneela laser. For second type is gas lasers. So here the examples for the gas laser is helium-ion laser and carbon dioxide laser. The third one is semiconductor diode lasers. Here the examples for the semiconductor diode lasers, gallium arsenide laser and indium phosphate laser. So these are the different types of lasers. So today I will explain about the solid state lasers. So the example for the solid state laser is Ruby laser. So I will explain its construction, working and applications of Ruby laser. So first, Ruby laser is the first type of laser, and it is demonstrated in the year of 1960 by Maimon. And the Ruby laser is a solid state laser, and it is means the active medium is available in the form of solid form, and it is a pulsed 3-level pumping scheme. Means here the 3 energy levels will be participated for the light amplification process. So if you look at the diagram, this is the energy level diagram for 3-level laser. So the lasers are available in the market either in 3-level laser or 4-level laser system. So here the Ruby laser is a 3-level laser system. Here 3 energy states will going to participate for the light amplification process. So here, so first I will explain the working of 3-level laser system. The same mechanism will work for the Ruby laser also. So here, if you see, here 3 energy states will be there. One is E1, this is the ground state energy, lower energy state. And the second one is the E2. E2 is the metastable state, and this will act as a intermediate state between the high energy state and the ground state. The third one, E3, is the high energy state and excited state energy. Okay, so initially here, all the atoms are present in the ground state because the ground state is more stable than the high energy states. So initially atoms are present in the ground state even. So by absorbing ground state atoms to the pumping energy source, by taking the pumping energy, so these ground state atoms goes to the higher energy state. Okay. At higher energy state, the atoms cannot stay more time. So here the lifetime is very short. It means the lifetime of the excited state is 10 power minus 8 seconds. So after completion of this lifetime, the atoms automatically comes to the lower energy state. So after completion of lifetime, this high energy state atoms makes a transition from E3 to E2. So from E3 to E3 is the excited state and E2 is the metastable state. So this transition is sometimes it is a radiative transition or non-radiative transition. Okay. So the radiative transition is nothing but the emitted energy in the form of photons. If it is in the form of photons, the transition is called radiative transition. If the emitted energy in the form of phonons or in the form of heat, so that transition is called as non-radiative transition. So, but in case of Ruby laser, so much of heat is generated, so here the transition is non-radiative transition. So again, in the metastable state, so the atoms can stay more time in metastable state than in the excited state. So the metastable state lifetime is 10 power minus 3 seconds. So So after completion of lifetime at the excited state, the atoms comes to the metastable state by making the transition non-radiative transition. And again, so after completion of lifetime of metastable state, the atoms automatically spontaneously comes to the ground state, means even state. So that is occurs due to spontaneous emission. So due to this, it emits a photon of energy hν. Again, this photon. So this is the spontaneous emission. So this photon is due to spontaneous emission. So after completion of metastable state lifetime, the atoms comes to metastable state to ground state by spontaneously by emitting photon of energy hν. Okay. So again, this photon will interact with the metastable state atom. So this helps to sending atoms from metastable state to ground state by emitting photons due to stimulated emission. So here the photons gets multiplied due to stimulated emission of radiation. Okay. So these photons will help for the amplification of light in case of lasers. So this is the working of 3-level lasers. So what is the first step? The first transition is the pumping transition. The ground state atoms takes the pumping energy source and goes to the higher energy state. That transition is called E1 to E3. Transition is called pumping transition. And the second one, E3 to E2, it is a radiative or non-radiative transition. That transition is E2 to E3 transition is radiative or non-radiative transition will occur. And the third transition is E2 to E1. That is the one is spontaneous emission transition. And the E2 to E1, again, one more transition will occur, that is stimulated emission of radiation. Okay. So this is a basic working of 3-level laser. So if you come to the Ruby laser, so in case of Ruby laser, it is a solid state laser and it is a 3-level laser. Here in case of Ruby laser, the active medium is, here we use the Ruby rod. It is made up with the Al2O3 and Cr2O3 crystals. So mainly the laser source comes from the Cr3 plus ions. So here Cr3 plus ions are the active ions. And some of the aluminum atoms are replaced with the chromium ions with the percentage of 0.05%. And the lasing action can take place in the chromium energy levels. So here Cr3 plus ions will participate in the for the lasing action, for amplification of light in case of lasers. Okay, so this is about active medium. And the second one is energy source. Here, in case of Ruby laser, the pumping source is pumping method is optical pumping by using xenon flash lamp. So here the pumping methods are also different for different type of lasers. So for example, if you consider the Ruby laser, the pumping source is optical pumping. If you consider the helium-ion laser, for example, for helium-ion laser case, the pumping source is electric discharge pumping. And if you consider the semiconductor laser, the pumping source is a direct pumping. So as we are using in case of semiconductor lasers, we are using direct bandgap semiconductors. So pumping source is direct pumping. Okay, and then so next comes to the construction of Ruby laser. Here, so this is a schematic diagram for the Ruby laser. Here, Ruby laser consists of a cylindrical shaped Ruby rod. So here, at both the ends, the two mirrors were fixed. So one is the fully reflecting mirror, and the second one is partially reflecting mirror. So the combination of two mirrors are called resonant cavity or optical resonator. So here the role of this optical resonator is to capture all the photons which are present in the active medium. Okay, so that the laser beam will comes out from the partially reflecting mirror. Okay, and here the Ruby crystal is placed along the axis of the helical xenon flash lamp with high intensity, and this is surrounded by the reflector. The Ruby, so in this process, in case of Ruby laser, during this process, so much of heat is generated. So in order to remove the excess heat, So we'll use the coolants. It means the ruby rod is protected from heat by enclosing it in a hollow tube through which cold water is circulated, so that we can remove the excess heat during the process. And the ends of this flash lamp is connected to the high energy source, so that the lamp gives flashes of an intense light. So this flashlight is connected to high voltage source. So it gives the flashes of an intense light. Next, coming to the working of ruby laser. So initially, the chromium in this ruby laser, the chromium ions are responsible for the stimulated emission of radiation, whereas aluminum and oxygen ions are passive, sustaining the lasing action. So this is the energy level diagram for the chromium ions. So this is the ground state, this is a metastable state and high energy state. So initially the atoms are present in the ground state. Cr3 plus ions are present at the ground state. Okay. So this is the pumping source energy. It is in the wavelength order of 5600 angstroms. So we are using the pumping source as this much wavelength. So this ground state atom Cr3 plus ions absorbs this wavelength 5600 angstroms and goes to the higher energy state. So at higher energy state, the Cr3 plus ions cannot stay more time. So after completion of lifetime, so it makes the non-radiative transition, and transition occurs from Cr3 plus ions coming from higher energy state to metastable state. So at metastable state, the atoms can be present at the metastable state, and then so the population inversion is achieved between the metastable state and the ground state. So after completion of lifetime in the metastable state, so here the lifetime is 10 power minus 8 seconds. So here this lifetime is 10 power minus 3 seconds. So after completion of this lifetime, atoms automatically comes to the ground state by spontaneous emission of radiation. So with the emission of photon, that is in the order of wavelength 6943 angstroms. Again, this photon will interact with the metastable state atom, and this photon will help the atoms coming from metastable state to ground state by emitting two photons. So one is the emitted photon, one is the incident photon. So the emitted photons will have the wavelength of lambda is equals to 6943 angstroms. So that the amplification of light can be done in case of lasers. The lasing action can be done with this wavelength. So in case of ruby lasers, the emitted wavelength is in the order of 6943 angstroms, which falls under the visible region. So in this way, this is the working mechanism for the ruby laser. Next, applications of ruby laser. So ruby lasers are used in distance measurement using pulse echo technique, and ruby laser is used to create halograms of large objects such as aircraft tiles to look for weaknesses in the lining. And these are also used in holograms to record the 3D objects. And these are used in atmospheric ranging, scattering studies, and lidar measurements. So ruby lasers were used mainly in research. One of the main industrial application is drilling holes through the diamond. And these are used in military as target designators and range finders, and to target the aim. And the ruby lasers are used in research applications such as plasma production and fluorescence spectroscopy. And these were extensively used in tattoos and hair removal. So these are the few applications of ruby lasers. And it has a few drawbacks. So those are ruby laser is a 3-level pumping source. So generally it requires a very high pumping power, and efficiency is very less. So only it can absorb the two components, those are green and blue. So and the remaining components are left unused, and the output coming from this laser is not continuous. It is in a pulsing mode. So the output coming from this Ruby laser is a pulsed mode, so it is not a continuous mode. So this is the one major drawback for this Ruby laser. So these are the few drawbacks for Ruby lasers. So with this, I'll summarize today's class. First, I have explained the main components of lasers. So on each role of each and every component we have discussed. And then based on the nature of active medium, the lasers are classified into different types. Those are major types are solid state lasers, liquid lasers, gas lasers, and semiconductor laser. So today I've discussed the solid state laser. So the example for the solid state laser is Ruby laser. So I've explained the construction, working, applications and drawbacks of Ruby laser. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.